natural gas piping. This is sleeves for new gas services must terminate 1 foot outside the property line and 1 inch inside the property line. What this is, when we're putting a new gas service in Con Ed territory, we're required to drill a hole through the wall and put the sleeve, which is a steel pipe. It has to penetrate the building wall, the building line, 1 foot past and 1 inch on the inside. We also have to grout that sleeve so that no water can come inside. When that's done, it kind of will approve to put the new gas service in. So a lot of this information might be foreign to you. You might see it. You might be doing it as a mechanic or a helper. But when you do become a leader and you're running your job site, it's going to make sense. You know, all this will click in. On high pressure gas, we've made the change. We're going all Schedule 80 pipe, which is extra heavy pipe, on high pressure gas. Schedule 80 pipe and nipples. If you don't have Schedule 80 pipe and nipples on the inlet side of the regulator, we're doing something wrong. Make sure you're using it. We made the change already, but you might be mixed in. Maybe the materials got separated. Everyone knows the difference between high pressure Schedule 80 and Schedule 40. Anybody? Schedule 80 is heavier. It's much heavier. When you pick up a Schedule 80 pipe or nipple, it's about double the weight of the regular nipple. And the wall thickness is double the size. That allows us, it handles much more pressure and it allows us to tighten it better. And now we're going to use 150 PSI American-made malleable fittings. All right. In the past, we might have been using some imported materials that are definitely not made as well. This is actually in the code. We need to use 150 PSI American-made black malleable fittings on the inlet of all gas regulators. If you don't see a marking, usually it's Ward or Stockham, and it'll have 150 stamp on it. Look for that when you're working on the gas lines. I'm sorry? We don't like Chinese pipe. We like Chinese food. We don't like Chinese pipe. Schedule 40 black pipe on the sleeves inside of the building. That's a plumbing code. We cannot use PVC on a sleeve. Now, a sleeve is a penetration in the wall. We have to put a sleeve to protect the gas pipe from corrosion. That sleeve has to be Schedule 40 black pipe. PVC is not allowed inside the building. Now, you'll see an anomaly here. Con Edison actually has approved PVC sleeves outside, going outside the building, in the wall. We'll decide that on a case-by-case basis. It'll usually show us on the form whether PVC is approved for that type of sleeve. Inside the building, and you should use sleeves on all the pipe penetrations, even the oil piping. If it's penetrating the wall and you're wrapping cement around it, you're going to smear the cement right up against that pipe. If moisture gets on it, that cement, the lime in that cement, will corrode that black pipe over time. So it's always a good idea to use a sleeve in the wall. But it's a code that you use it on gas piping. Fire stopping. Fire stopping is a code, and fire stopping is that red. I think it's made by Hilti or some other manufacturer, and it's rated for, I don't know, 7,500 degrees. I really don't know what it's rated for. I'm sure Vinny could tell me because he's a melancholy. We'll get into that later. But the sleeve is red. The caulking is red, and it prevents the fire from jumping from one room to the next inside the annular space inside the sleeve. This is another thing that we've been getting knocked on, and it's really a Con Ed specification. On all your gas stands, you can even do it at the gas train. We have to have the red rubber insulating gasket, and that prevents, it's a grounding, it prevents any loose electric from going into the gas line. It insulates the rubber from the ground. You have to put the red rubber around the riser clamps completely, and I've been seeing that. We're getting better with it, but there's quite a few out there that are still missing. Let's start doing that on a daily basis. You have a question about that?
They want to insulate it from ground up, but water comes from the building down because you're hanging the hangers from the ceiling.
It's a good point. There probably should be insulation around every hangar. We haven't gotten that far in the code yet. I've actually heard of some of the gas customer service representatives looking for that, but it's not code and we don't have to do it yet. But it is a good point. Right now we're going to give them what they want so we can get the job to turn on. Yes.
I found out from a couple of inspections of the gas line, in the meter room itself, where hanging pipe, they want the rubber underneath the cover.
That's where I heard it from. You told me that already.
They don't carry it for the meter room, just in the meter room only.
All right, so what Anthony's saying is inside the gas meter room, when you're running your gas piping from the meter room out to another room, usually a hallway, and then into the boiler room or wherever it goes, every hanger in that room needs to have a red rubber insulated gasket underneath the hanger. This is something that you've been gigged on already?
They didn't bother me on it, because I found out take care of it. 598 West 177. I did see probably people there, I said, no problem, I'll take care of it.
You know what? Yeah, go ahead, Ben. You want to add to that?
Yeah, Con Edison's jurisdiction ends at the meter room. Outside the meter room is the Department of Buildings. So Con Edison is looking for this. They can't leave you outside.
Let me take that one step further. Con Edison's responsibility, or any utility's responsibility, is from the meter to the wall. Every piece of pipe that goes from the service entrance, the gas valve, the main valve, and every piece of pipe right up into the meter is Con Ed's responsibility. That's why they tell us we have to insulate the stands. That's their specification. Everything from the meter piping out. Let me back up. It's called gas service before the meter. It's called gas distribution after the meter. Gas distribution's jurisdiction is Department of Buildings. New York City Department of Buildings does not have the requirement to insulate the hangars. So if Mr. Henry wants to fight on that, we might want to fight with him a little bit. Only because it's past his jurisdiction. Meter piping out, he has nothing to say about it, unless it's leaking. Beyond that, he has no control. So let's leave that alone for now. We're gonna do what we've been doing. Yes.
So it's not the meter room, it's gas service.
Gas service is from the street all the way to the meter inlet. That's considered gas service.
After the meter, then.
It's called house distribution, gas distribution, which is Department of Building jurisdiction. Gas service is Con Edison jurisdiction. They can dictate whatever they want on the inlet side of that meter, and we have to comply.
That's the only reason I'm saying with the car before their meter, it's coming off the head service.
Yes.
In the meter room.
Before their meter, they have jurisdiction. If they say put red rubber, put red rubber. If they say put feathers, we're putting feathers. That's what we're doing. Tighten all nuts on hangers and threaded rods. Vinny mentioned this. This is not only a pet peeve of mine, it drives me crazy. Not only on gas piping, but on oil piping, on steam piping, on every piece of pipe we put up, there's a hanger system. And that hanger system, countless occasions that I found those nuts that lock the cross member into the clevis hanger, those nuts are loose. The threaded rod coming out of a ceiling should have a lock nut on the top and a lock nut on the bottom of the hanger. And those lock nuts, when everything is said and done, you have to walk through the building and go through every one of those hangers and lock everything down. That ensures that they will not shake loose. Buildings vibrate, everything shifts and moves. You'll always find a hanger on the floor, or at least loose. When it comes to loose hangers, everyone has a problem with that. All right, it's not good for the piping system, and it's against the code. So let's be vigilant about checking our hangers. This is something that we've started to do. We've had a lot of problems where when we first turn the gas on, if we don't purge the debris that's inside the pipe, welding slag left in the pipe, that's a no-no. You have to get rid of that welding slag somehow. We could do it during the test when we're putting up 50 pounds. We have 50 pounds from the meter outlet all the way to the gas train inlet valve. All right, let's blow that out before we tie the train in. With that 50 pounds of pressure, blow out the debris, put a little rag or something in front of the gas train, and let that pressure go, and it'll take all the debris out so that we don't have that debris clogging up the gas train and the mechanism that's going to control the gas system. This is something that we're doing on gas starts, and I want to make sure that that we're doing it religiously. If we're not doing it, let's start now. This next item, a manometer test on the entire gas system prior to startup. What that is up to 14 inches of water column. We're using the YouTube manometer, and we're testing the entire system prior to startup. That means after we tie in the meter, that means after we connect the gas train valve to the train, after we purge out all the air, everything is open, all our pressure switches are on, the gas booster has its transducer to switch on the train, everything is in place, the gas, every switch that has to be used, we have to put a 14-inch water column test on the entire system prior to startup. We were having countless failures on the final connections where we would have leaks at the trains. And by the way, we should be testing to the trains. I'm sorry, I forgot your name. Fabian, I apologize for that. Sanguine. We'll get into that in a minute. We could test through the train. We test on the inlet and outlet of that valve. You have a little gauge. We could put a 4 inches or 14 inches of water column on the inlet of that train up to the valve and on the outlet of the train. You don't have to wait for the startup to determine if the gas train is leaking. How many times in the past have we taken apart gas trains during the startup when everyone's waiting, everyone's annoyed? We're now doing that ahead of time. Pre-start, this is something we're starting to do, and it's working. We have much less problems with our gas starts now. So let's keep doing it. This is something I added in, and this is something that we're going to start doing because it seems like we have a little bit of a epidemic of leaks on high pressure gas after we leave the job. We went last night, we had a call 2 years that job's been online. Now that's not something we're going to see the next day, but that's something that we have to address. This is high pressure gas, and we do gas starts, we do boosters. The problem is the foreman is onto another job site, so it's up to the managers to make sure we get somebody back the following day to confirm that there are no leaks. Because a lot of times leaks creep in overnight, especially on high pressure gas. So we're going to make it part of our religion to go back to these sites the next day to soap everything up again, sniff around, let's make sure there's no problems. Countless occasions, the next day or two, it shows up, Con Ed comes, and we're in an emergency situation, and we don't need to do that anymore. Anybody have any questions about gas piping at this point? Anybody? Alex?
Subject to add, this has been complaining about the vertical installation of a gas train requires a
Drip leg.
drip.
Very good point. We are, on some occasions, mounting the gas trains vertically on the way down. The first one we did not put a drip leg on it. We did not purge out the gas line. And we opened up the booster and we sent all the debris and it lodged into the gas train. And we basically had to take a $1,700 gas train that was just apart and thrown in the garbage. To combat that, we're actually installing a drip leg somewhere before the turn down into the gas train. Fabian did a great job on a job on West 86th Street. He just simply made an elbow, a T, and then a cap on the bottom, and then he went horizontally, and then he made another elbow down into the train. That was a beautiful arrangement. That's something that we should preach to everyone as we go. If we're going to mount them horizontally, we have to have a drip pocket. So that's a good point, Alex. Thank you. Before the train, okay? No, we did that already. Sorry, guys. In your handouts, page 30. This is some issues. By the way, I made copies of the entire gas piping installation of the New York City 2008 plumbing code for your use. I'm not going to go over every item. You need to take some time yourself and learn this. And it's not something you're going to learn simply by reading. You're going to learn it by bringing it to the job site and doing it. That's how I learn. I'm a visual learner. Specifically, 403.7, 403.7, and that's on page 30, down at the bottom left side. I want to read this out. Workmanship and defects. Pipe fittings shall be clear and free from cutting burrs and defects in structures of threads. They shall be thoroughly brushed and chipped and scaled blown. What does that mean? We was talking about it outside, about bad threads on gas piping. And bad threads on any type of system is no good. Specifically on gas piping, because people's lives are at stake here. When you're done with the thread, if it has a defect, do not use that thread. Make another thread. That goes to the setting of the dies. If you have bad dies, you need to get them fixed. We can't use bad threads. You have to clean all the oil out of inside and outside of that pipe with the clean rag. That oil will break down the compound over time. If you put compound on a nipple with oil sitting on it, the oil will break down the compound, and the leak won't happen right away, but a few months from now, you're going to have a leak. So that has to be free and clear. It has to be perfectly dry. Thoroughly brushed, all the chips removed with the wire brush. Jeff had a great idea. He said we should probably get everyone a mini wire wheel on the job sites that you could plug in as part of your tools. Anybody like that idea? A little wire wheel on the side that you can actually put the threads up against before you screw them in? It's a thought, something we could discuss. So that's an idea. If it's clean and if you run your hand across the thread and it could cut your finger, it's no good. It's got to be smooth. All right, it's very important. Any questions on threads? Any questions on that at all? Yes. Well, that should be done anyway. Any kind of power tools, you should be wearing your safety goggles. We're doing grinding all the time. We're doing welding all the time. We're cutting with sawzalls. There's chips and burrs flying all over the place. So when you're using power tools, you have to have power goggles anyway. If not, make sure you have them. All right? But that's a good point. You would definitely need goggles. All right, defects in pipe and fitting shall not be repaired. Defective pipe and fitting shall be replaced. That's the end of 403.7. 403.9.1. That's in the middle on the right side. Pipe with threads that are stripped, chipped, corroded, or otherwise damaged shall not be used. Where a weld open, let me stop there. I'm going to emphasize that again. We're not using bad threads. And by the way, this is not Dan Giganti saying this. This is the New York City Plumbing Code. This is our Bible. We live by this. So let's stop. Where a weld opens during the operation of a cutting or threading, that portion of pipe shall not be used. What they're talking about is some of the cheaper brands of pipe are welded seams. We use A53 pipe. If you don't see A53 on it, talk to us. We're getting Korean pipe and stuff. We stopped using that. We're using coated pipe at all times now. I want to go down to the table specifically on threads. The number of threads, 403.9.2. Now, if you look at this table, on the left side, if you see 1/2 inch, 3/4, 1 inch pipe sizes, if you look all the way to the right, you should have 10 threads. If you have 12 and 13, you're making the threads too long, therefore making them too thick, and they're not going to seal properly. So let's start using that. This is a good table here. Let's start using that, guys. 1.25 inch, 1.5 inch, 2 inch pipe should have 11 threads. This is right out of the code book. This is not me talking. 2.5 inch pipe, 3 inch pipe should have 12 threads on it. And if we go to 4 inch pipe, we should have 13 threads. Let's do it. Well, you know what? I'm learning, teaching you, because not that I didn't know this, I forgot this. And this is all stuff that, it's great that we're doing this, because this is, we don't have to guess anymore. We know what to do now, all right? Thread compounds. This is something that, it's not, blue block is not in the code, by the way, 403.9.3. What is in the code is that the thread joint compounds, pipe those, shall be resistant to the action of liquefied petroleum gas or any other chemical constituents of the gases to be conducted through the pipe. It's got to be resistant to the gas. Can't be a water-based. We have the blue block is what we're going with, especially on gas. We having success, guys. Anybody note any differences? We changed about a month ago. Any feedback I need, please. You find it better than the pipe dope?
Messy, but it's working.
Okay. Well, we got hand cleaner for that. We can clean up the mess. So let's continue to use the blue block. I think it's working. If anybody has any better compound, I'm open. Right now we're going with blue block. And let's go with the interval of supports. In the back of your book, page 38. And again, this is all. Can I have that for a second? Let me have yours. I don't have it in front of me here. I want to keep that one there. It's actually on the back page. There it is. The last page, it's actually on the back. It's 4.415.1, the interval of support. This is for steel pipe on the left side, ½ inch. You have to have spacing. Thank you, Laura. I heard that. It took me a while. I put it up here, right? There it is. Never mind. I got it up here. All right. Thank you. So for ½ inch pipe, and these are smaller pipes, we got to have 6 feet of horizontal. Every 6 feet, we have to have a hanger. Every 6 feet. If it's 3/4 or 1 inch, every 8 feet there has to be a hanger. 1.25 or larger, every 10 feet. Okay, this is going across. On the vertical, it's every floor, going up and down. That would be a riser clamp. Now, this is something I added here. So every 10 feet, we're dealing with mostly 3 inch and 4 inch, 2.5 inch, 3 inch, 4 inch, 5 inch pipe. So every 10 feet is the rule of thumb. I added this. Before and after each wall penetration. When we're running the gas line through a wall, you have to make believe the wall's not there. I see the wall being used as support. That's a violation. Imagine the wall's not there. Have a hanger before and a hanger after within 10 feet. Okay? When we're making every turn, or 90-degree turn, before and after each elbow. Now, if you have one at 4 feet, and you don't need one right at the elbow. But if you have one at 10 feet away, put one at the elbow, and then put one around 4 feet on the other side. And then it'll start your next 10-foot run. So it's very important that we're doing that properly. Excuse me. Talk amongst yourselves. All right. Any questions? This is also good use on any type of piping. This doesn't have to be just for gas piping. We could do this with oil piping. Yes.
All the time, all the pipe is that line. What happened about that line?
I can't hear you. What are you asking me?
No. All the time, many buildings, many houses on the water. What happened about that line?
They need to replace them.
Right?
What are you going to do? Especially if it's gas-fired equipment. Any gas-fired equipment, electrical, has to be replaced by code. You cannot reuse that. Because 6 months from now, when that salt water starts eating through it, you're going to have a problem. I guess it gives us a lot of work, guys. I mean, Sandy was good to us. I mean, it was bad to us personally, but it was good to us, professionally. I want to talk about, this is regulated gas vent installations. This is a Con Ed drawing, EO 17118. It's in the handout that you guys have. I broke it down into a couple of different segments. When we're running out, we're running gas vent pipes. You have to, each elbow has an equivalent developed length of feet. If you put a 3/4 elbow, you actually added 2 feet of pipe to it. So if the limit is 20 feet on that vent, you add 3 elbows, that's 6 feet. If you have 20 feet more of pipe, you're over the limit. You're at 26 feet because each elbow in 3/4 inch is equivalent to 2 feet of piping. The same thing with 1 inch. Each 1 inch elbow is 2 feet of piping. Now, we're usually dealing with the larger pipe sizes. Every 3 inch elbow is equal to 7 feet of pipe. Now, what does that mean? The limit for that 3 inch pipe is 20 feet. 2 elbows, 6 feet of pipe is all you can put on there. And a lot of times we'll want to go right through the wall. We've been added 3, 4 elbows. Automatically, if you use 3 elbows, you have to go to 4-inch on the entire vent coming from the regulator going outside. Look at this. Every 4-inch elbow is equivalent to 10 feet of pipe. All right, so keep that in mind. If you got 4 elbows, you have to talk to someone. And at 3-inch, we're doing something wrong. Sure.
On a 45, 4-inch, what would that be?
Doesn't say up here. There's no code on it that says 45. I would imagine 2 45s would be equivalent to it. But I haven't. This is the location, prohibited locations of gas vents. If you have a gas vent coming out anywhere in this area, it's prohibited. Let's say if you're coming out of the wall here, that's fine, but you can't terminate the vent head. You must move outside this 18-inch protected zone. 18 inches to the right, 18 inches to the left, and at least 18 inches above grade in Con Ed territory. Now, it doesn't matter how far up that window is. That window could be up 3 stories up. If you think a pipe at the sidewalk would be safe to stick the vent head there with the window 3 stories up, we're wrong. You have to go up the whole building and look to see that there's no windows in that pad. Kind of crazy, but that's what they want. So this is a restricted area for vent heads. On this side, I'm going to move over here, I like this. As wherever possible, if we could just drill that hole and stick that vent right through the wall and face the PEX vent down, that's what I want. Okay? So we don't have outside, we don't have pipes, making turns outside. Wherever possible, let's try to do this. This is a really good way to do vent piping. All right, we were talking about fittings, okay? I just want to note this. This is a part of the spec. If you look here, it calls for malleable iron 150 psi. So that's a specification for the vent fittings. This is describing the elbows. This is the gas regulator sizes, 1 by 1 by 3/4. Okay, it has to go with a 3/4 inch vent. 1 by 1.25 inches by 1, it goes with a 1-inch vent. 2 by 2 by 2.5, 3-inch vent. We've had those vent terminals are 2.5 inch. You can't take that, put a adjust coupling, and run it outside. You must increase it to 3-inch right away, and then go out with 3-inch. And here's what we were talking about. This is the limitations of the lengths of the vents. Up to 20 feet, that's the maximum for 3/4 inch. 1 inch, 3-inch, and 2-inch on these regulator sizes. See on the bottom they're actually giving you the model numbers of the regulators down here. And you'll get to know this. As you start doing Con Ed layouts, you'll get this. All right? If you have to go above 21 feet, you can see that 3/4 inch vent goes up to 1 inch. They want to have bigger capacity to be able to handle the restriction, the friction loss in that pipe to get that vent out the building quickly. For this 1.25 inch, these are the ones we're dealing with now, especially out in Clearview. You got to go to 1.5 inch pipe if you're over 20 feet. So if you have 1 inch is what? 4. Let me go back. Every 1 inch elbow is 2 feet, right? Thank you. 2 feet. So if you have 4 elbows, that's already 8 feet of pipe, and 13 feet of pipe. 4 elbows is 8 feet pipe equivalent, and 13 feet of developed length of pipe. And developed length, anybody know what that means? That's through the elbow. So you're counting every inch of that pipe. How many? It's every inch. So developed length. So you have 21 feet. You have to jump up that pipe size to 1.5 inch. It's a big difference. I mean, we want to keep it inside of the 20-foot dimension if possible. We could save a few bucks doing it that way. Yes, you have a question.
Now, what happens if you have a wall work?
You increase the pipe size. I'll show you. 21 feet to 40 feet. They're actually telling us to put the pipe size bigger. The same regulator, the pipe jumps up from 1 inch to 1.5 inches. Same regulator, pipe jumps from 3/4 to 1 inch. Up on the other side, these are very common regulators here. The 2-inch regulator, 2 by 2 by 2.5. We see these on almost every one of our jobs. We have to set that pipe up to 4 inch. And we're only allowed to go up to 40 feet, which means we still have to be careful of the elbows. 4-inch elbow. I know. 10 feet. 3 elbows, 10 feet of pipe, we're at 40 feet already. Think about that. So when we get above that, there is a little bit of leeway, but I don't want to bring it up here. I mean, when we get above that, then we have to contact gas measurement and wait 3 months for them to get back to us. So let's keep it short. All right, Con Edison is notorious for taking a while to get back with us. These are notes. Vent pipe must be gas tight. We're supposed to be testing them. We can't have leaks on them. Be properly supported. Terminate outdoors with the vent cap facing downward. And they must be sized according to table 1, which we went over. For vents larger than 20 feet equivalent. The entire length of the pipe shall be the larger pipe size. So what that means, if you have to increase the pipe size, you can't take 20 feet of 3-inch pipe and then increase it to 4-inch pipe. Once it's determined that you're past 20 feet, the entire length has to be 4-inch, including the dresser coupling. So you would start with a 2.5 by 4 increaser on the outlet of the regulator, put your dresser coupling right there, and run the whole length 4-inch pipe. Shall not be located directly under a window or any opening leading back into the premises. That's just common sense. These regulators will leak. We don't want the gas going back in the building. We want it outside where it's safe. If the vent outlet is lower than the adjacent opening, it must be laterally offset by 18 inches to the nearest vertical line of any opening or projection that could allow gas to enter the building or accumulate. We went over that. And if outlet cannot be laterally offset by at least 18 inches, it must discharge above and away from any opening or an overhang. Very, very silly. But let's say we have a vent pipe coming out over here, and we see there's no window, so we stick the vent head here. We have a problem. We have an overhang. That's no good. They don't want the gas to get trapped up in this overhang. They actually will require you to bring it up and around and away from the overhang so that gas can freely go up into the atmosphere. All right, that's a very important fact. Look over your head when you're setting that up. All right, the vent cap shall be a weather and insect resistant fitting. We buy those fittings. They actually have screens on them. We don't want any bugs flying in. It can't be covered in any way. Can't have any equipment up against it. You can't park a car against it. Install a tag to identify the curb valve location in New York City. If vent cap is used, it's not worded gas. So basically it has to be identified as a gas vent head.